We have a function p of x which is equals to a to the power x, and then on our graph we have the point a which is our y-intercept, and then some point t lying on the first quadrant, as you can see. And then the first question 7.1 is saying let's find the coordinates of point a, right? So we've already established that point a is our y-intercept. So if point a is indeed our y-intercept, then it should have an x value of 0, right, and some value of y which we're supposed to find. So for us to find that value of y, we just have to substitute 0 into our equation p of x, right? So we can say that p of 0 will be equals to a to the power 0, but we know fully well that any number to the power 0 is 1, so we have p of 0 being equals to 1, right? So for the coordinates of a, we have an x value of 0 and a y value of 1, right? And just like that, we have the coordinates of point a. And then now moving to the second question 7.2, it is saying that let's calculate the value of a, right, the variable in our equation. So we know that p of x is equals to a to the power x. Now we need that value of a. So what we can do here, we can substitute the coordinates of point t, which is 5 and 32, right, as we can clearly see. So the y value of p of x at point t, that is 32, and we're looking for a, and then to the power x, x is 5, right? So let's write 32 with the base of 2 and the power of 5. So we're gonna have 2 to the power of 5 being equals to a to the power of 5, right? 2 to the power of 5 is just 32. So we can drop the exponents and equate the bases. So if we do that, we get 2 is equals to a, and then now we know that p of x is equals to 2 to the power x, right? And then we have determined the value of a. Now let's move to 7.3. So 7.3 is saying that let's write down the domain of p. So we know that p of x is equals to 2 to the power of x. So if you look at this equation here, you will realize that it is defined for all negative values of x, and it is also defined for all positive values of x. It's also defined at x is equals to 0, right? So we can say that the domain of our function p, we're running from minus infinity and then to positive infinity, right? It is defined for all values of x, or you can write instead x is an element of real numbers, right? Yeah, but then we just want to see that you are aware that this function is defined for all values of x. And then 7.4 is saying that let's write down the equation of p inverse in the form y is equals to. So let's not forget, we know fully well that p of x is equals to 2 to the power of x. So if we want to find the inverse, we have to swap x and y, right, and then solve for y. So if we do that, in place of p of x, we put in x, we swap in x and y, right, then it's equals to 2 to the power y. And then from here on, we have y as our exponent, so we have to introduce log on both sides. If we do that, we're gonna get log of x being equals to log of 2 to the power y, and then on the left hand side we're gonna have log of x still, and then on the right hand side we can drop the exponent, which is y now because we've introduced log, right? So we're gonna have y multiplied by log of 2. It's easy to see now that we're just dividing both sides by log of 2. So if we do that, we're gonna get y is equals to log of x divided by log of 2, right? And we can further simplify that into log of x base 2, right? And just like that, we have our inverse in the form of y is equals to. And then off to 7.5. So 7.5 is saying let's determine the values of x if p inverse of x is less or equals to 5, right? So what is p inverse of x? Is what we just calculated in 7.4, right? So we have log of x base 2 being less or equals to 5. So let's go ahead and solve this. If we do that, we're gonna get x being less or equals to 2 to the power of 5. So x is less or equals to 2 to the power of 5. We've already established above that this is equals to 32, right? And then just like that, we have the values of x for which p inverse of x is less or equals to 5, right? But then there's another restriction. We're talking about log of x base 2, right? And we cannot take log of a negative number or log of 0, right? So we have to also indicate that we need this x value to be greater than 0, right? Because if it is 0 or less than, then we have issues arising. So we need the value of x to be greater than 0.